Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 11th Physics, Work, Energy and Power, Chapter 6 ncert Solution, Part 2. Our mission is to provide free classes on YouTube for all students of Class 6 to Class 12 and students who are preparing for IIT, JEE, NET, NDA and other competitive examinations. Before we begin, we request you to subscribe, like and share our channel among your friends and relatives, and please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Now, today we'll begin with 6.11 because we have completed 6.10 in the last class. So 6.11 question is a body constrained to move along z-axis of a coordinate system and is subject to a constant force F given by F is equal to minus I plus 2J plus 3K Newton, where I, J, K are unit vectors along x, y and z axis in the system respectively. What is the work done by this force in moving the body a distance of 4 meter along the z axis? Let us see the solution. So the solution is force exerted on body F is equal to minus I plus 2J plus 3K Newton. Displacement S is equal to 4K meter. Work done W is equal to F dot S. So the dot product of minus I plus 2J plus 3K dot 4K is equal to given by and which is equal to 12 joule. Hence 12 joule of work is done by the force on the body. So let us see the next problem. The next problem is 6.12. An electron and a proton are detected in a cosmic ray experiment. The first with kinetic energy of 10 keV and the second with 100 keV. Which is faster, the electron or the proton? Obtain the ratio of their speed. Mass of the electron and protons are given and the value of electron volt is also given. So let us see the solution. Electron is faster. Ratio of the speed is 13.54 is to 1. This is the answer. But how we get the answer? Let us see. Mass of the electron m e is equal to 9.11 into 10 to the power minus 31 kg. Mass of the proton mp is equal to 1.67 into 10 to the power minus 27 kg. Kinetic energy of the electron Ke is equal to 10 keV, that is 10 to the power 4 electron volt, is equal to 10 to the power 4 into 1.6 into 10 to the power minus 19, which is equal to 1.6 into 10 to the power minus 15 joule. Kinetic energy of the proton KEP is equal to 100 keV, which is equal to 10 to the power 5 electron volt, is equal to 1.6 into 10 to the power minus 14 joule. Both the velocity of the electron Ve and its kinetic energy is given by the relation Ek E is equal to half mVe square. Ve is equal to under root 2 multiplied by Eke upon m. Putting the values, we get 5.93 into 10 to the power 7 meter per second. For the velocity of proton Vp, its kinetic energy is given by the relation Ekp is equal to half mvp square. Vp is equal to under root 2 multiplied by Ekp upon m. Putting the values, we get 4.38 multiplied by 10 to the power 6 meter per second. Hence, the electron is moving faster than proton. The ratio of the speeds Ve upon Vp, putting the values, we get 13.54 is to 1. Let us see the next question. So the next question is 6.13. A raindrop of radius 2 mm falls from a height of 500 meter above the ground. It falls with decreasing acceleration due to viscous resistance of the air until at half its original height it attains its maximum terminal speed and moves with uniform speed thereafter. What is the force done by the gravitational force on the drop in the first and second half of its journey? What is the work done by resistive force in the either in the entire journey if the speed of reaching the ground is 10 meter per second? Let us see the solution. So radius of the raindrop r is equal to 2 mm, that is 2 into 10 to the power minus 3 meter. Volume of the raindrop V is equal to 4 by 3 pi r cube, which is equal to 4 by 3, 3.14 multiplied by 2 to the power 10 to the power minus 3 to the power 3 meter per meter cube. Density of the water rho is equal to 10 to the power 3 kilogram per meter cube. Mass of the raindrop m is equal to rho into V. Putting the values, we get 4 by 3 multiplied by 3.14 multiplied by 2 multiplied by 10 to the power minus 3 to the power 3 multiplied by 10 to the power 3 kg. Gravitational force F is equal to mg. Putting the values, we get 4 by 3 multiplied by 3.14 multiplied by 2 to the power 10 to the power minus 3 to the power 3 multiplied by 10 to the power 3 multiplied by 9.8 Newton. The work done by gravitational force on the drop in the first half of its journey W1 is equal to Fs. Putting the values, we get 4 by 3 multiplied by 3.14 multiplied by 2 to the power 10 to the power minus 3 to the power 3 multiplied by 10 to the power 3 multiplied by 9.8 multiplied by 250, and upon calculating we get answer as 0.082 joule. The amount of work done is equal to the work done by the gravitational force on the drop in the second half of its journey. Work done is equal to W is equal to 0.082 joule. As per the law of conservation of energy, if no resistive force is present, then total energy of the raindrop will remain same. Total energy at the top Et is equal to mgh plus 2 plus 0. Putting the value of mg and h, we get 0.164 J joule. Now, due to the presence of resistive force, the drop hits the ground with a velocity of 10 meter per second. Total energy at the ground, Eg is equal to half mv square plus 0. Putting the values and upon calculating, we get 1.675 multiplied by 10 to the power minus 3 joule. Therefore, resistive force Eg minus Et, resistive force is equal to Eg minus Et. Upon calculation, we get upon calculating we get minus 0.62 joule. Let us see the next problem. Next problem is 6.14. A molecule in a gas container hits the horizontal wall with a speed of 200 meter per second and angle 30 degree with the normal. The and rebounds with the same speed. Is momentum conserved in the collision? Is collision elastic or inelastic? हाँ बोल. Yes, collision is elastic. The momentum of the gas molecule remains conserved there whether the collision is elastic or inelastic. The gas molecule moves with a velocity of 200 meter per second and strikes the stationary wall on the container, rebounds with the same speed. It shows that the rebound velocity of the wall remains zero, hence total kinetic energy of the molecule remains conserved during the collision. This gives the given collision is an example of elastic collision. Let us see the next problem. The next problem is 6.15. A pump on a ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and the efficiency of the pump is 30%, how much electric power is consumed by the pump? Let us see the solution. Volume of the tank V is equal to 30 meter cube. Time of operation T is equal to 15 minutes, that is 15 into 60, that is 900 seconds. Height of the tank H is equal to 40 meter. Efficiency of the pump neta is equal to 30%. Density of water 10 to the power 3 kilogram per meter cube. Mass of the water M is equal to rho V is equal to 30 multiplied by 10 to the power 3 kg. Output power can be obtained as P0 work done upon time, that is mgh upon T. Putting the values 30 multiplied by 10 to the power 3 multiplied by 9.8 multiplied by 40 divided by 900 upon calculation, we get 13.067 multiplied by 10 to the power 3 watt. The input power Pi efficiency neta is given by the relation neta is equal to P0 upon Pi is equal to 30%. Putting the values, we get Pi is equal to 13.067 upon 30. Multiply by 100 multiply by 10 to the power 3. Upon calculating, we get 0.436 multiplied by 10 to the power 5 watt. We can write it as 43.6 kilowatt. Let us see the next problem. 6. Next question is 6.16. Two identical ball bearings in contact with each other and resting on a frictionless table are hit head on by another ball bearing of the same mass moving initially with a speed v. If the collision of elastic is elastic, which of the following in figure 6.14 is possible result after collision? The answer is case 2. Let us see the explanation. It can be observed that total momentum before and after collision in each case is constant. For an elastic collision, the total kinetic energy of a system remains conserved before and after collision. For mass of each ball bearing m, we can write total kinetic energy of the system before collision, that is half mv square plus half multiplied by 2m multiplied by 0, that is half mv square. So case 1, it is total kinetic energy of the system after collision, that is half m multiplied by 0 plus half multiplied by 2m multiplied by v upon 2 whole square. Upon solving, we get 1 by 4 mv square. Hence, the kinetic energy of the system is not conserved in case 1. Let us consider the case 2. In case 2, total kinetic energy of the system after collision is half 2 multiplied by 2m multiplied by 0 plus half mv square. Upon solving, we get half mv square. Hence, the kinetic energy of the system is conserved in case 2. Case 3. In case 3, total kinetic energy of the system after collision is half multiplied by 3m multiplied by v by 3 whole square, that is 1 by 6 mv square. Hence, the kinetic energy of the system is not conserved in case 3. Let us see the next problem. So, the next problem 6.17 is the bob A of a pendulum release from 30-degree to the vertical hits from 30-degree to the vertical hits another ball of the same mass at rest on the table as shown in the figure 6.15. How high does the bob A raise after the collision? Neglect the size of the bob and assume the collision to be elastic. The answer is bob A will not rise at all. Why? Let us see the explanation. In an elastic collision between two equal masses in which one is stationary while the other is moving with some velocity, the stationary mass acquires the same velocity while the moving mass immediately comes to rest after collision. In this case, a complete transfer of momentum takes place from moving mass to the stationary mass. Hence, bob A of mass m after colliding with bob B of equal mass will come to rest while bob B will move with a velocity of bob A at the instant of collision. Let us see the next problem, that is 6.18. The bob of a pendulum is released from a horizontal position. If the length of the pendulum is 1.5 meter, what is the speed with which the bob arrives at a lowermost point, given that it dissipated 5% of its initial energy against air resistance? Okay, let us see the solution. Length of the pendulum L is equal to 1.5 meter. Mass of the bob is equal to m. Energy dissipated is equal to 5%. According to the law of conservation of energy, total energy of the system remains constant. At horizontal position, at the horizontal position, potential energy of the bob EP is equal to mgl. Kinetic energy of the bob EK is equal to 0. Total energy total energy is equal to EP plus EK, that is mgl plus 0, that is mgl. This is equation 1. At lowest position, at lowest point, that is mean position, potential energy of the bob EP is equal to 0. Kinetic energy of the bob EK is equal to half mv square. Total energy EP is equal to EP plus EK, that is 0 plus half mv square, that is half mv square. This is equation number 2. At the bob, as the bob moves from horizontal position to the lowermost position, 5% energy gets dissipated. The total energy at the lowermost position is equal to 95% of the total energy of the horizontal point. That is, half mv square is equal to 95 upon 100 multiplied by mgl. That is, V is equal to under root 2 multiplied by 95 multiplied by 1.5 multiplied by 9.8 upon 100. Upon solving, we get the value as 5.28 meter per second. Let us see the next problem. So the next problem is 6.19. A trolley of mass 300 kg carrying a sandbag of 25 kg is moving uniformly with a speed of 27 km per hour on a frictionless track. After a while, sand starts leaking out of the hole on the floor of the trolley at a rate of 0.05 kg per second. What is the speed of the trolley after entire sandbag is empty? Let us see the solution. So the sandbag is placed on a trolley that is moving with a uniform speed of 27 km per hour. The external force acting on the system of the sandbag and the trolley is 0. When the sand starts leaking, action does not produce any external force on the system. This is accordance with the Newton's first law of motion. Hence, the speed of the trolley remains 27 km per hour. Let us see the next question. 6.20. A body of mass 0.5 kg travels in a straight line with a velocity v is equal to a x to the power 3 by 2, where a is equal to 5 meter 5 m to the power minus half per second. What is the work done by the net force during its displacement from x is equal to 0 to x is equal to 2 meter? So mass of the body m is equal to zero point 0.5 kg. Velocity of the body is governed by the equation v is equal to ax to the power 3 by 2, with a is equal to 5 meter 5 m to the power minus half per second. Initial velocity u is equal u at x is equal to 0 is equal to 0. Final velocity v at x is equal to 2 meter is equal to 10 to the power root 2 meter per second. Work done W is equal to half m v square minus u square. Putting the value of m, v and u, we get half 0.5 bracket 10 to the power root 2 whole square minus 0 square, which is equal to half multiply by 0.5 multiply by 10 multiply by 10 multiply by 2, which is equal to 50 joule. Let us see the next question. 6.21. The blades of a windmill sweeps out a circle of area A. A. If the wind flows at a velocity v perpendicular to the circle, what is the mass of the air passing through it and time t? B. What is the kinetic energy of the air? C. Assume that the windmill converts 25% of the wind's energy into electrical energy and that A is equal to 30 meter square, V is equal to 36 kilometer per hour, and the density of the air is 1.2 kilogram per meter cube. What is the electric power produced? What is the electrical power produced? Okay, let us see the solution. Area of the circle swept by the windmill is equal to A. Velocity of the wind is equal to V. Density of the air is rho. Volume of the wind flowing through the windmill per second is equal to AV. Mass of the wind flowing through the windmill per second is equal to rho A and V. Rho multiplied by A multiplied by V. Mass m of the wind flowing through the windmill in time t is equal to rho AV and into t. Kinetic energy of air is equal to half mv square. Putting the value of m, that is half rho avt v square, that is half rho avq t. Area of the circle swept by the windmill A is equal to 30 meters square. Velocity of the wind v is equal to 36 kilometer per hour. Density of the air rho is equal to 1.5 kilogram per meter cube. Electric energy produced 25% of the wind energy, that is 25 upon 100 multiplied by kinetic energy of the air, that is 1/8 rho avqt, that is 1/8 rho avq t upon t, that is 1/8 rho avq. Putting the values of rho av, we get 1 by 8 multiplied by 1.2 multiplied by 30 multiplied by 10 to the power 3 is equal to 44.5 multiplied by 10 to the power 3 watt, which is equal to 4.5 kilowatt. And this this is the end of today's session. Before we close, we request you to subscribe, like, and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much for watching our channel and supporting us. Thank you.